Yeah, good afternoon. So I'll be talking today about reusable launch vehicles. Launch vehicle, as you know, it's a rocket powered vehicle which is used to place a payload or take a payload from Earth's surface to outer space. And this payload can be either a crewed spacecraft or it can be a satellite. And when this vehicle is used again and again for this purpose, it is termed as a reusable launch vehicle. And the main purpose of going for reusable launch vehicles is to reduce the cost of access to space, or to reduce the cost of launching satellites into space. Now, this the satellites, it can be classified in different ways. One of the classification is based on the function that it carries out. Depending upon the function, satellites are classified as communication, remote sensing, or weather satellites, military satellites, rescue or space telescopes. This is one type of classification, and all of them mainly apply advanced technology for the benefit of mankind, and they provide a wide range of societal services. Another classification is based on the mass of the satellite. A satellite need not necessarily be of very high mass. There are very small satellites. One example is the Sprite, which is a very tiny satellite. It's only 3.5 centimeter by 3.5 centimeter and weighs only 4 grams. But still, it's a single board spacecraft having its own microcontroller, radio, solar cells, and lot of sensors. And in fact, we had sent 6 of them in our TEDxIITRoorkee mission. There are satellites. These are called as femto satellites. Then pico, nano, like that, different satellites are there. But there are very huge satellites also, which weigh more than even 10,000 kg, like the Hubble Space Telescope. It weighs almost more than 10 tons. So there are wide range of applications that satellite supports, like the telecommunication, the TV broadcasting, search and rescue, satellite news gathering, or cyclone warning services. In the area of remote sensing, again they support agriculture, land use, water resources. One interesting application is what is known as a potential fishing zone, where we give predictions. India has got a very large coastline, and we give predictions to the fishermen situated across different coastline, like where they can get a good catch of fish. And this reduces the time taken for fishing, as well as they get a very good catch of fish based on these predictions. Then soil mapping, forest mapping, disaster warning, flood damage assessment, all these are applications of satellites. Satellites are also used for space exploration, to know more about our planet, our own Earth, or about the Sun, other planets in the solar system. And they are also used to find answers to a number of questions about the origins of the universe, like what you see here. Another area which is fast picking up is space tourism. Space tourism, as you can see, that is Demis Keto, the first space tourist, and Ocean Seri, the first women space tourist. And in spite of the huge cost, there are people who have even gone twice to space. It costs something like 100 crore rupees, but there are people who have gone twice paying that amount. So that shows the interest people are having, and this is an area which is fast picking up. In fact, there was a survey which was conducted by a magazine on what are the top 10 trips of a lifetime, travel dreams, and out of which one particular travel dream is blasting off on a Virgin Galactic flight. It's one of the, in addition to maybe calling on all the 7 continents or photographing the big 5, this is one particular travel dream which people have mentioned. And in fact, this is the flight profile. The Virgin Galactic vehicle, it can take you to outer space. The edge of space is what is known as a Kármán line. It's 100 kilometers. So it will take you above that, and you will experience a few seconds of weightlessness. So this is one area which is fast picking up. Then of course new applications are coming up, like harnessing of the solar power from space, like setting up large solar panels in space well as search for exoplanets. Exoplanets are planets outside the solar system, habitable planets, and in fact after the Hubble Space Telescope has been deployed as on March 1st, we have almost discovered 5,640 such exoplanets. So this keeps on increasing, and in fact it's estimated that in our Milky Way itself there are about 11 billion habitable planets like the Earth. So search for exoplanets is another application of satellites. So you see, because of all these, there is an increased demand to go to space, and for that you need launch vehicles. But Yuri Gagarin made his first space flight on April 21st, 1961. But in the 63 years of human space flight, you will find that only 681 people have made it to space. So that's a very small number, 63 years and 681 people, okay, on an average 10 to 11 persons per year. Why is it so? And space is something which is not that far off. If you see, space is just 100 kilometers above. The carbon line is only 100 kilometers above. But only people are not able to go to space in spite of so it being so near. What is the reason? See, I am coming from Trivandrum. Yesterday I travelled by an A320 aircraft. If you see the typical cost of an aircraft, baseline price, if you see something like 650 to 700 crores. Now, I paid only 12,000 rupees for that trip from Trivandrum to Delhi. From Delhi I travelled by road. 12,000 rupees. But if you see the cost of the aircraft, 650 to 700 crores. Why is it that the airlines is able to give me a ticket at such a cheap price? It's because they are using that aircraft again and again. Suppose if you throw away that aircraft after coming from Trivandrum to Delhi, you throw away the aircraft. Just see what will be the price. 700 crores, and an A320 aircraft can carry something like 180 people. So you divide by that, it will be something like 4 crore per flight. So same is the situation here. If you want to bring down the cost, you have to reuse the vehicle again and again. And that's exactly the point which I am telling on topic which I am telling, reusable launch vehicle. If you want to bring down the cost of launching satellites or bring down the cost of access to space, you need to reuse the launch vehicle, and that's known as the reusable launch vehicle. So we have increased transponders, heavy satellites are there, space tourism is picking up, space habitat, human-rated vehicles are required, and scientific explorations. All this, because of all this, the cost of space, access to space has to be significantly reduced, and space travel has to be made more frequent and cheap. Now how to do it? Already many companies have started doing this. This is one such vehicle which is known as a New Shepard, which they have reused again and again. The same booster has been used in 7 flights. Another company which has been successful is Falcon 9 of Elon Musk. They have the SpaceX Falcon 9 family of vehicles, where a booster is used as many times as 19 times they have used it, and the turnaround time is something like 45 days. So these are some of the successful companies. Now what I am showing here is a typical multi-stage vehicle which we in ISRO is using. It's a GSLV. So you can see that after deploying, these are the different stages of the vehicle. So as the launch vehicle goes, you can see that these different stages are expended in this scene. And finally, after the satellite is ejected, you don't have the vehicle to be used again and again. Now let's look at the elements of cost. How much does what mainly contributes mainly to the cost of a launch vehicle? If you see, almost 70%, 60 to 70% of the cost of a launch vehicle goes into the mechanical hardware, which is the material and the fabrication cost. And the propellant cost and consumables, that's about 18%, and operational cost is about 10 to 20%. So if you see, the major chunk, the 60 to 70% of the cost of the launch vehicle goes for the material or the mechanical hardware which we are expending this. So that's where if you are able to reuse this again and again, the launch vehicle cost can bring it down. And if you see another thing is, if you see the lift-off weight, almost 70% of the lift-off weight of the launch vehicle consists of oxygen, the oxidizer. That oxygen and 80% of that oxidizer is consumed during the atmospheric phase, which happens only in the initial few seconds. So if you are able to make use of this atmospheric oxygen, then you can substitute this oxidizer mass with the payload mass, which in turn will reduce the cost of access to space. So this is another concept. So we can improve the payload capability either reusing or using the atmospheric oxygen. So if you combine all these options, you get what is known as an advanced reusable launch vehicle. You have to reuse the stages as well as you should be able to use the atmospheric oxygen. And when we talk of reusable launch vehicles, the world's first partially reusable launch vehicle is known as the Space Shuttle of NASA. You can see the orbiter that we can reuse, but the solid boosters and the other liquid tanks that we are not able to reuse. But the orbiter is being reused again and again, and it has in fact been in operation for more than 30 years and has delivered number of payloads to space, including the construction of the International Space Station was possible. Almost 35 missions were there from the space shuttle for construction of the International Space Station, and the servicing of the Hubble Space Telescope and all was carried out through this only. It is a successful partially reusable launch vehicle. So there are different concepts. You can either have a single stage to orbit reusable launch vehicle, or there can be two stages. The reusability can be partial like the space shuttle, or it can be full. Then there are different configurations. It can be a vertical takeoff or horizontal takeoff. Then the staging can be tandem, parallel. The choice all depends on the technology which you are having currently with you. And this is just a picture of aircraft flying all over the world. At any time, if you go and take a snapshot, this will be what it looks like. So you can see that aircrafts are flying left and right all over the world. So a concept similar to this, like an aircraft, you go to space, deploy the satellite, come back and land, refuel, again go for the next mission. This is one of the concepts which many people have been trying, and if you are able to do that, then you can decrease the cost of access to space. So some of the technologies that you should have are mainly the thermal protection system, reusable tanks, and you have to manage a wider range of flight environment, unlike an aircraft. It varies from 0 to 25, so you have to manage the thermal management of the system through thermal protection system, aerodynamic characterization, precise navigation systems are required. All this if you are able to develop, then we can have a fully reusable launch vehicle. So towards this, ISRO has also been working in this area, and we have conceived a technology demonstrator which is known as a reusable launch vehicle technology demonstrator. And we have multiple phases for this program. The first took place on 23rd May 2016. It was the first hypersonic flight in the country. Hypersonic means greater than Mach 5. So successfully we launched it from Sriharikota, and it landed in the Bay of Bengal after performing the necessary maneuvers. Second is landing experiment. We successfully carried out a fully autonomous landing experiment on April 2nd, 23rd. And you would have seen yesterday, today's newspaper, if you have seen yesterday, there was a similar mission that was a repeat of the same with slightly off-nominal conditions. In the next phase, we are going to take this winged body to our orbit, and from there it will come and land on a runway. And we are also working on a vertical landing. So this is the flight profile of the X mission. We launched it using a booster, and it achieved Mach number 5, and subsequently it has re-entered, and after performing the landing maneuvers, it has splashed down in the Bay of Bengal. And all the objectives were met. Mainly it was the first hypersonic flight in the country, greater than Mach 5, or controlled landing maneuvers, everything was demonstrated. This is the flight profile of the landing experiment. We have used a Chinook helicopter and taken the same vehicle to about 4.5 km. Then it is released, and it is fully autonomously, it has come back and landed in the runway in TEDxIITRoorkee. This was a mission yesterday we have carried out for off-nominal conditions. So this is some of the photographs of the approach, the shallow glide, and the ground roll phase of the mission. And the importance of this mission is that this is the fastest landing ever carried out in Indian soil by aircraft. The landing speed is as high as 325 km per hour. This is the fastest landing of an aircraft in India. Yesterday we have repeated it again. And this was on April 2nd. And we have used advanced navigational aids like the K-band radar altimeter as well as the pseudolight system. And landing gears also were indigenously made. And this you can see. And next we are going in for the orbital range experiment. We are using a modified version of the GSLV vehicle. We will take the vehicle to orbit, and it will come and land on a runway. So after that, we also have parallel programs running on air breathing propulsion, where the oxygen, atmospheric oxygen, will be reused and used, and that engine will be working, and we will integrate both of this, and we will go for an advanced reusable launch vehicle. And in fact, last month Prime Minister visited, Honorable Prime Minister of India visited VSSC, and we were all thrilled when he named our vehicle as Pushpak. You would have seen that yesterday was the landing of the vehicle Pushpak in Chitraduga. Okay, just taking a relook of our knowledge of history. Pushpak is actually it was originally made by Vishwakarma for the Lord Brahma, and he gave it to Kubera, and then Ravana has actually captured it from Kubera, and then after Lord Rama won over Ravana, he has returned it back to Kubera. Now this name Pushpak is really ideal for our vehicle because it has something to do with money. And what we are trying to do is reduce the cost of access to space. Once we have this, the cost of access to space will come down, and actually, that means more business, more people will come to us for launching their satellites. So the name seems to be apt. So in conclusion, I would like to tell that the present launch vehicles, they use expendable launch vehicles, and to reduce the cost of access to space, we should have RLVs. And already the technologies for an RLV are complex, and we also have our program. In 2007 we had the space capsule re-entry experiment, then we had the hypersonic flight experiment in 2016, then we had the landing experiment and also the scramjet experiment, and these have all been successful, and the design and development of RLV is really challenging, and for the next generation there are a lot of opportunities, lot of technologies to be demonstrated. So that design and development of an RLV is a real challenge for the next generation. So with that, I conclude my talk. Thanks for your attention.